Question 14. A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following function F models the remaining amount of the substance in grams t years later? Okay. So this one here, we can, if you take a peek at the answer choices, all these are, well, this is exponential function. All right, so exponential function, we know that because t is in the exponent. Okay, so we were thinking about an exponential model here for this one. So for exponential equation, the general form is y equal to a times b to the x power. Okay, but this one we're doing a modeling, so it's gonna be, remember for a modeling question, the a value is always gonna be some initial amount. Right, it's a number that we begin with. And graphically speaking, this will be the y-intercept. Okay, so it's the number that we begin with. So here it is at the initial amount of the substance is 325. So that should be the number in front. Okay, so that should be the a value, which is 325. Okay. And then inside the parentheses here, this will be the either the growth factor or the decay factor. So this question we have a decay, right? So we're getting less and less for the radioactive substance. So this will be the decay factor. Right. Okay, that's the decay factor. So that means for each year, right, this will be the number that we multiply from 1 year to the next, right, to get to the next number. So they told us the substance decreased by 13% each year, but we have to be careful. This, we cannot just put 13% inside of parentheses, not 0.13. So to find the decay factor, we have to subtract from 1. Okay, you have to subtract from 1. So we do 1 minus 0.13. That will give us 0.87. And this will be the decay factor. Okay, so whenever we have a decay, we subtract from 1. So what it really means is, you think about 1 is like 100%. So that's the original amount, right? So we're starting with 100% and we're getting 13% less. So we subtract 13% and we have how much left? Well, 87% left. So that's how we get 0.87. So that means next year we're only gonna have 87% of what we have right now this year. So that's why it's 0.87. Okay, so if we have a percent increase, right, so we add to 1. Okay, percent decrease like this one, we subtract from 1. And that will be the number that goes inside parentheses, which is 0.87. Okay, and our exponent here will be t that represent the number of years. So for most exponential model, t, yeah, so the exponent will be a measure of time, right? Or that's years, days, or hours, minutes, that usually is representing time. Okay, so our best answer here will be A for number 14.